In this video, we're going to be going over some more techniques, some problems in which we can use combinatorics. So let's get started. So we have a 4x2 grid here, and what I'm going to start off by doing is we're just going to count the number of ways we can get from point A to point B, assuming this is point B and point A is right up here. Alright. And in this problem, we can only go to the down or right. So what we can do in this problem is we can go from A to B in a way such that, so we go down, right, all the way to B. But what we can't do, that's acceptable, but what we can't do is go from A to B in this way. So down, right, up, something like this, and then doing it all over again. And then getting a B, that's unacceptable. So we cannot do that. We can only go to the we can only go down or to the right. And if we think about this, this restriction makes it a little bit easier for us. But we still we can't just draw everything out. That's going to take too long and it's not efficient. We might end up making mistakes and stuff like that. So what we're going to do is we're going to find a more efficient way to count this out. And well, what I'm going to do is I'm going to start with a smaller grid. So we're going to move to the next slide and we're going to do a smaller grid. So let's say I had something like this, a 2x2 grid, and this is point A and this is point B. So to get from point A to point B, I can go here, I can go here, I can go here. I already counted that. So as you can see, it's still pretty difficult to count this out. So we're still going to have to use a technique to count like this, from A to B. And the way we're going to do this, we're going to start even smaller by just a square. And let's see when I get from point A to point B using only the square. So we look at this and there's only two ways. We can start at point A, we can go down here, take a right, or we can go down here and come down here just to get to point B. So there are two ways we can do that. But how do we get to this answer? That's the real question here. That's how we're going to get to the answer of this problem, and that's how we're going to get to the answer of the 4x2 grid. So over here, what we're really doing is, well, we're going down or to the right. That's what we're doing, right? So we're going down once and to the right once, right? In this problem, what we're doing is we're going down. Well, starting at A, we go 1, 2, and we start from here, we go 1, 2. So we're going, in this problem, we're going 2D and 2R. Over here, we're going 1D, 1R, and 1 down, 1 right. This makes for a total of 2, but we're not going to add them. Because if we add them, that's not how we're going to do this. And the reason we're not going to add them is because we're choosing which paths to go. We're going to choose out of this, which makes us think of combinatorics, and it's choose one because there is one way down or one way right. So essentially in these type of problems, you want to first find out the total of down and right or whatever paths you want to take, add them up. So over here we're going to take 4 and then choose either the down or the right. So over here it's 2D and 2R, so it's 4 choose 2, which can be computed. So the answer to this is 6. And the answer to this is obviously 2. We already know that. But the way we got to this is 2 choose 1, which is the most important part of the problem. The way we got to 6 is 4 choose 2. So now we know how to handle these type of problems. So we're going to go back to the grid problem, and we're going to start off. We're going to count how many ways we're going down and to the right. So going down, we go 1, 2, and we're going to the right 1, 2, 3, 4. Okay, so over here we're going 1, 2, 2 down, and to the right we're going 1, 2, 3, 4. So it's 4R, makes a total of 6, And know that 6 choose 4 is the same as 6 choose 2, as we learned in the previous combinatorics video, because 6 minus 4 is 2 and 6 choose 2 is obviously has that in the lower part of the combination. So we can use any of these, but since 6 choose 2 is easier to handle, I'm going to choose 6 to choose 2. So 6 times 5, 2 times 1, 2 and the 6 cancel, leaving the 3, and our answer is 15. So I mean, if you wanted to, you can go ahead and count out 15 times. That's going to take a while, but this way is definitely easier. And yeah, that's counting on a grid using combinatorics.